No, this is not a picture of me. This is a picture of my friend Ian. I worked with Ian a few years ago, and I was doing... Oh no! Look at Ian again. We were doing an agile transformation, and I was really new into this stuff, so I would go to all the conferences, and I would read all the books, and I would go to Ian, who is slightly more experienced, and would say, Ian, look at this book, you know how much I've learned? And Ian would listen to me very patiently, and then would go, okay, so what have you changed? And I would go, no, I've learned all this stuff, I'm yet to change everything, but it's fascinating learning. And then I would go to a conference, and I would go to Ian, and I would say, Ian, look at all this stuff that I've learned. And he would go, so what have you changed? And really, I did not understand what he mean. But hopefully, through the talk today, we'll try to explore that and find the answer to that question. What did Ian mean? So some years after that, I went to work for an organization called Emergent, and for about a year, we were trying to build an educational product. And at that point, I really had to delve into what is it that we mean by learning, and how do we learn best? And this is just one of the books that we produced as part of that one-year effort. But it really started opening my mind to what might have been the question that Ian was asking me. Right, my name is Marcin Floryan. You can find some of my thoughts on that blog. I currently work for this little fairy animal. Oh, actually, no, I don't. I work for a company called Compare the Market. And I've got a little question for you to start off with. So, who of the people who are here thinks that you are paid exclusively to learn? Right? Do you want to raise your hand if you think that's the case? Right. I can see 1, 2 hands up. Don't worry, I was prepared for that. So, let me ask you another question. When you start a project, how many of you know exactly what the end result will look like? Oh, all right, nobody. So when you start a project, how do you know exactly what set of requirements you will implement? Nobody again? So when you start a project, how many of you know, before you start, how many production servers there are going to be? Oh, I can't believe nobody's raising their hands here. So, for me, the process of going from the state where you don't know something to the state where you actually know how many servers there are in production, what you have built, and what requirements you've implemented, I call that learning. We live in software development land, which is product development for me. Learning is what we do, going from an unknown to known. And I would say that all of you here are paid exclusively to learn, because learning is what we do every single day, even if we don't recognize that. So I thought it was really brave of Paul to invite me here. And I will ask him to cover his ears now, because I'm going to tell you, today, you are not going to learn anything. Ignore that. I'll tell you more. In this conference, you are not going to learn a single thing. And this is not because the speakers are not good. They're excellent, right? They're the best you can get. Let's try to explore, why might I be trying to put through that heresy? And for that, we need some great philosophers, and I like where Russ started us, so let's go back to the ancient Greeks. I cannot teach anybody anything. I can only make them think. And then, to Socrates' kind of quote, Plutarch had a beautiful explanation why that is the case. For the correct analogy for the mind is not a vessel that needs filling, but a wood that needs igniting. Right? I'm hoping to ignite a few branches tonight. So, in order to learn and to actually battle this no-learning problem, we need 3 things. We need a pencil, some cogs, and a thumbs up. Make sense? No, of course not. So what I would like to share with you today, and if that's the takeaway you take, that's it, we're done. Learning to be effective needs to be primed, deliberate, and validated. Okay? Let's explore what that means. Primed learning. So very, very early on as human beings, we discovered that there is this land that we live on, and there are all these oceans that we would like to explore, and there are actually more oceans than the land. So we started kind of sailing out and further away, until we actually built ships big enough so that we can sail from one land to the other. And that was beautiful, and unfortunately, we realized that there was a little problem as we started sailing further and further away. That was the problem. Usually, on an average length voyage, half of the crew would die of scurvy. It is estimated that between 1500 and 1850, about 2 million people died of scurvy, 2 million sailors. So rather a big problem. So here is Lord Anson, who took a bunch of ships for about 3 years naval expedition to fight the Spanish. And on his expedition, on these beautiful ships, he took about 2,000 men, all right? So I would like you all to stand up now to try and kind of emphasize with what happened with these men. So you've already been standing up a lot, so I'll ask you to do it again, please. All right? Stand up, everyone, please. You represent 2,000 sailors, the 2,000 sailors that sailed with Lord Anson for 3 years, right? Now, how many of you think came back home? I would like you to sit down if you think you made it home. All right? So some people are sitting down. So what I'm going to ask you is, I'll tell you, it was 600 of them. A third made it home, right? So let's make this a third of the room. You guys can sit down, please. The rest of you, I'm really sorry, you didn't make it, okay? But there is one good outcome, right? You went fighting. So even though you died, it might have been honorable death if you actually managed to kind of fight some enemies. So how many of the people who are still standing, you think, actually died in battle? How many do you think should be standing? How many should be sitting down? So all you who just sat down, please stand up again. 3 men died in battle. All the rest died of scurvy. Thank you very much. Sit down, please. Now, of course, I asked you to stand up and sit down to kind of experience this a little bit, but you already know. We only did this little exercise, so your brain's got a little bit more oxygen so that you can actually absorb this talk a little bit better. So here comes James Lind, a Scottish guy who was trying to actually find the problems. And he was the first guy who did clinical experiments. He took sailors who were suffering from scurvy, and he divided them into nice little pairs, and each pair would be fed with different food. And he found out that one pair who would get citrus fruit was almost instantly cured of scurvy, right? So what he did, he shared that with everyone, and what people did? Went, nah, that can't be the food, we'll ignore that. So there's James Cook, right? 2 big expeditions, about 1750, 1760. He takes a ship, sails around the world, discovers Australia, comes back home. People think, wow, he's a great man. He goes away, takes his beautiful ship, sails around the world, comes back home, and guess what? Not a single man dies of scurvy. Okay? Everyone's surprised. What did James Cook do? Well, he had plenty of this on board. That was carrot marmalade. And he had plenty of this. That was some sauerkraut. So actually, he took all the things that he thought might influence this. But you know what? Actually, no learning. Cook got a medal for it, but the rest of the Navy just ignored that outcome. And for another 60 to 100 years, people kept dying out of scurvy because they didn't have the right food when they were sailing. This is Vienna General Hospital around 1840. Okay? And there were 2 clinics in which babies were born. So you think, they were just some experimentation with the sailors and some observations. So let's look what happens when we have data. Clinic 1, this is mortality rates of mothers who are trying to give birth to children in those 2 clinics. Which of the two clinics would you rather give birth to a child in? Right? I bet it would be the second one, right? And there was one guy working there, Ignaz Semmelweis, a doctor, a physician who was trying to really crack this problem. He was really, really uncomfortable that in one of the clinics the mothers will die much more than in the other one. So what he did was he tried to experiment and see what was the difference, and it took him months and years to discover. But eventually, one of his friends died because he was stabbed by a scalpel by one of the students. The difference between two clinics is one had students that were being taught medicine, the other didn't. And in the clinic where the students were being taught medicines, they would go from the autopsies to the mothers who were giving birth. So Semmelweis went, how about if you guys did this? Just wash your hands, see what happens. This is what happened. This is the mortality rate. Dropped off the cliff. Right? Fantastic. I'm really sorry. You know what happened to the guy? He got fired because the physicians could not bear the fact that they could have unclean hands. That was completely out of their minds. You know, it was completely so out there. So he goes somewhere else to another hospital where he tries to repeat the experiment. The results are exactly the same. So what does the other hospital do? They put him into a mental institution where he dies. No learning there. So after Semmelweis, we have this idea of Semmelweis reflex, which is our instant reflex to reject any ideas that do not fit with what we've already learned. This is why we don't learn, right? So what does it look like in software? Here is Kent Beck. And this is his quote from about 20 years ago about functional languages. In spite of their conceptual and mathematical elegance, functional programming languages never caught on for commercial software, period. They're dead. Anyone doing JavaScript today? Still alive? So, you know, one of the reasons why we're not learning is because it is impossible for anyone to begin to learn that which he thinks he already knows. How often do we think we already know these things? So, learning to be effective needs to be primed, and that means you need to be prepared. You need to have planned your learning before you start. Anyone knows what this is? Looks like a spreadsheet. It is a spreadsheet, and I borrowed it from Jürgen Appello. And this is a spreadsheet that Jürgen prepares to track his learning when he's writing a book. You think that's his spreadsheet? That's what it really is. That's how detailed he is about his preparation. All right, so learning to be effective needs to be primed, deliberate, validated. Let's look at deliberate learning. My daughter is learning how to do ice skating. And she's doing these lessons, and after a set of lessons, she goes into a next level. And to go to the next level, she needs to have completed a number of exercises. So after, she was about to go from level 2 to level 3. And the teacher said, you're really good, but you need to do this one exercise better to go to level 3. So we go together on ice, and she goes and tries to do some more exercise. And what I see her do, she's doing all the exercises she already knows how to do, not the one the teacher told her to improve on. Okay? Anyone seen a developer's CV where it says 10 years of Java experience? Okay? They're doing the same thing over and over again. 10 years wasn't enough to realize that Java was a dead end. No disrespect to any Java developers. You can put any language you want in there. So actually what we need is not just practice, we need deliberate practice. And the difference between normal practice and deliberate practice is that we practice not what we're good at. This is what you were going to do, just working on your code every day. It is the deliberate practice which is practicing the things we're actually not good at, putting effort into improving our skills and our performance. So there is a gentleman called Mihail Csikszentmihalyi. A little bit of Hungarian notation there for you. he came up with this idea of flow. And this is how he was trying to explain what this deliberate practice is. So the deliberate practice occurs when the relationship of your existing skills and the challenges you face is just right. Not too difficult, not too easy. Because if your challenges are too simple for the skills you have, you're just bored. But if the challenges are too difficult for the skills that you have, you get so much anxiety you can't do anything. You have to find the right sweet spot. I've been talking a lot about practice, but when people say about learning, they usually don't necessarily mean practice. They very often mean knowledge, right? So obviously mastery of the knowledge alone isn't sufficient. We have to have both. And this is the one thing that I really learned at VFQ, that for our learning to be effective, we have to do both. Theory and practice. And I'm just going to put it here in front of you, and I encourage you to go and research that a little bit more. This is something called the Kolb learning cycle, and that's all the universities using today to teach their students. And what they're saying is that in order for you to learn, you have to go through the whole cycle. And the cycle, you can start it wherever you want, but usually it starts with some concrete experience. You've done something, you've heard something. Then you have some reflective observation, right? You do abstract conceptualization, so you turn what you saw into what you think is a model in your head. And then you do some active experimentation on that subject. This is why you guys cannot learn anything today, because there's no way you can go through the whole cycle just during the conference. Hopefully, you'll get lots of ideas, but you have to think about them, and you have to put them into action. Now, Epictetus also tells us something very important about this deliberate learning. Now, this is translated from Greek, and even in English it doesn't make sense. So what he really said is, if you want to do something, just go and do it. But if you want to stop doing something, you have to start doing something else. We're really bad at unlearning things. Children are brilliant learners because they don't have to unlearn anything. And we're usually not in that comfortable position. So I have a little story for you to illustrate that. So long time ago, there was a beautiful castle, and in that castle lived a king, and that king had an alchemist, as many kings would, right? And why would the king keep the alchemist in his castle? Because he was hoping that the alchemist would find the right formula for turning whatever iron ore into gold. But the alchemist kept failing. So the king gets really anxious and goes, "Now, that's it. You have 6 months to come up with a formula so that I can actually get my gold." So the alchemist goes away, thinks about it, comes back and says, Dear king, actually, I think I have found your formula. This is your formula, but in order to get your gold, you have to follow this formula really, really carefully, step by step, on your own. But remember, the most important thing of all, when you're doing that, you have to remember never ever to think about the dragon that lives under the castle. So I'm going to set some expectations, and I'm glad that I've already seen this curve twice. As you go into deliberate practice, as you start your learning, you're going to go from here, down here, and up there. And the poor Java developer that I was referring to earlier, he probably stayed over there, never made the jump to the next level. This looks very beautiful, but in practice it won't look like this. So this is an example of Jerry Weinberg tracking his pinball abilities over many, many years and his improvements. This is what the graph really looks like. And that's what you should be prepared for. That's what you should expect when you go learning stuff. So learning to be effective needs to be primed, deliberate, validated. Let's talk about validated learning. My children have quite a few books, and for some strange reason, every night when I go and read a story for them, out of all the books that they have, they pick just the one. And I open the book, and I sit with them, and I'll read. Who lives inside this little house? It's Toffel all alone. Poor Toffel doesn't notice quite how lonely he has grown. And on and on and on it goes. And every time I make a mistake, my children know I've made a mistake. And if I close the book and I try that and try to memorize this, no chance. However, there's this book. And this book I can just read even now, even today, after 20 years. Litwo, ojczyzno moja, ty jesteś jak zdrowie. Ile cię cenić trzeba, ten tylko się dowie, kto cię stracił. I think many of you might remember that. So what's the difference between the book that I read for 6 months every night to my children, I can't remember it, and a little poem that I read 20 years ago, and I can still recite it here in front of you, even though I'm shaking nervous, right? What is the difference? The validation. I had to read this in front of a teacher. I was tested on it. Fortunately, my children only test me slightly on the book that I read to them every night about TOEFL. And the important thing that we're trying to battle here when we try to get our confirmation, our validation of the learning, is the confirmation bias, which is our natural tendency to confirm what we think is true. We read a book, we think it had some really good ideas. Hey presto, I've learned it, right? So how do we confirm these things? How do we make sure that there is not just me who thinks it's the case? You know, Olaf was talking about it. How do you get someone else to help you out? Some experiments with psychology students about training. It turns out that if you take students, put them through training, one team and another group of students doesn't get the same training, even if the training is worthless, the students who went through the training will remember that it has improved their abilities, their skills, and that they had done better after the training, even if there is absolutely no observable difference. Confirmation bias. Another thing we're trying to fight here is something called the Dunning-Kruger effect, which says that if we don't know that much, if we're not really very good, we tend to overestimate our abilities. Novice developers will think they're better than they really are. However, seasoned, really good developers will tend to underestimate their abilities. And apparently this is tied to the fact that the young novice developers overestimate their own ability, but the seasoned developers will overestimate others' abilities. And we have to remember that our memory is a save-on-read memory, is save-on-recall. If we want to remember something, we have to recall something, but not only just repeat it, but actually try to recall it and use it in a context. Get that practical element into your learning. All right, any questions? No, I'm not allowing you for questions now. We'll have the open space for that. Questions are a very important thing, very important way to validate your learning. And how many of you will be asking questions? How often would you like to ask a question and you don't? How many of you have been taught at school not to query your teachers, not to ask them any questions? So, going back to Ian, now I understand why he was asking me, what have you changed? Because he wanted me to really learn, and he already understood that true learning takes the full process, and then only by demonstrating that I have done something with my learning, only when I do that, only when I change something, can I truly say that I've learned. All right? Do you guys remember? Primed, deliberate, validated. Okay? Repetition is good for learning. Primed, deliberate, validated, effective learning. So I'm going to finish off with this theory of learning entropy, and this is just my idea. So what I've been doing just now was this. These are the ideas that I've been throwing towards you. That is not learning. That is just a random piece of blocks that I'll have to pick up later on. But in order to actually build something from these blocks, I would have to put some energy, some effort into it. And I want you guys to remember that you have to put effort into your learning in order to build something from the random facts that arrive into your brains. All right? So for me, when I started on this journey and I wanted to share my ideas about learning, one very important validation would be to actually come up here and share those ideas with me. So I'm here because I'm trying to validate my learning about learning. And I'm going to finish with this great quote from Seth Godin. If you've done something with what you've learned, then maybe you know it. Right? Primed, deliberate, validated. Maybe. Thank you very much.